Hello, this is Colton Carmichael, and this is my final project presentation. So the way I approached the first script for this project was to write the pseudocode, so I could sort of get my ideas organized and everything. So the first thing I wanted to do with the first script was to ask the user to input the coefficients of the linear system and the initial conditions, and then I use these values to calculate the discriminant of the system. And then using the discriminant of the system, I would use the if statement to see if the discriminant is positive, and if so, then I calculate the zero response for the non-repeating roots. And then else, if the discriminant is zero, then I calculate the zero input response for the repeating roots. And then else, if the discriminant is negative, then I calculate the zero input response for the complex roots. And then at the end of the main file, I'll print the zero input response for the appropriate case. So as you can see here, for question 1 from YouTube video, I inputted the A1 and A2 values and or the coefficients and the initial conditions of the first question in the YouTube video, and I got the correct answer. Same here with question 2, got that answer right here, and then question 3 here. So yeah, that was my approach for the script 1 part of the final project, and then here's script 2. So the approach I took to this was to prompt the user to input the number of zero input responses they'd like to calculate, which would be set as the n variable. And then after that, I would open the data file, the data text file in read mode, and I'd create an array that has n rows and 4 columns. So the array has n rows because pretty much each row represents its own system and value, and the each column pretty much represents each value in that system. So I set. So the next step was to set the row and column. Set row equal to n and column equal to 4, since we are using 4 parameters to calculate zero input response. And this is how the 4 values of the system are ordered in the data text file. So that's why I said respectively as ordered. And then the next step was to go through each value in the data text file and set the corresponding array value equal to it. And then after that, I close the data text file and open the result text file. And this time I'd open it in write mode because we're going to be outputting our calculations into this file right here. So then I'd go through each row or system in the array and set A1 and A2 and Y0 and DY0 to their respective values from the array. And then I'd calculate the discriminant of the system using these values. And if the discriminant is positive, calculate the zero input response for non-repeating roots. And then this would be printed out in the result text file for that. And if the discriminant is zero, calculate the zero input response for repeating roots. And that's how that would be uh, exported into the result file. And the discriminant is negative, calculate zero input response for complex roots. And this is how that would be outputted into the result text file. And then after all that, I'd print the zero input response for the appropriate case and close the result text file. And then as you can see here, this was using the result or the script 2. So this is my data text file that I used. So this is the A1s, the A2s, the Ys, and the Y derivatives right here. And then this is the result text file that it gave me. So from this project, I learned mostly about file input, file output structures. And I also learned how to use a file as a parameter, as you can see here. I did that for the zero input response, and I also learned how to state the parameter in the user defined function using this. So yeah, I learned that from doing this code, but most of it was just coding with the file input and file output structures. What I learned, most other knowledge came from previous homeworks and stuff. But the most difficult thing was probably all learning all the knowledge from modules 10 through 12 and to learn how to write this code and use the files, because that code was probably the hardest thing we've learned throughout the class, I'd say. And so yeah, my opinion about this project. So at first I was very frustrated using the file input and file output structures and code grammar. So that was very hard at first, but about halfway through the project, I started to get relieved because it started to actually become fun to organize all my code and reorganize all the user-defined functions and put certain parts of my code in a header file. So yeah, that part of the project was pretty fun, but that was towards the end of the project. So yeah, that's my project presentation for this final project. So this is my first script. This is the main file for it. And if you're wondering why I'm using online GDB, it's because there's some problem with inputting files the uh, from the same folder as in my Xcode project file. So I'm just using online GDB because I can just easily upload it using this right here. So yeah, well, anyways, this is my first scripts main file. So I declared the initial conditions and the coefficients of the linear systems, and I asked the user here to enter the coefficients and the initial conditions, and then I use the this user defined function right here, this zero input response, and I use these variables that they enter as the parameters. And this user defined function is within the script1 header file. So we'll go to that right now. And at the very bottom is where the zero input response user defined function is located. So in this user defined function, I first calculated the discriminant, and I use this discriminant to decide if it was a non-repeating root, repeating root, or complex root. And then I did the respective calculations here, and I also made user-defined functions to calculate the C values of the non-repeating roots. So that's done up here. So C1 and C2 non-repeating is right here, and they calculate the C values of the non-repeating roots, and then it would print the non-repeating zero input response here using this printf line. And then, so if it's not a non-repeating root, then the code would follow down to this else if statement, where this else if statement is basically made for the repeating roots, and if that's when the discriminant equals 0. So I initialized this array to hold the C values for this repeating root and calculated the roots of that, and I calculated the C values using these user-defined functions here, and those are located right here. So you calculate C1 and C2 for the repeating roots, and then the else statement, which does the calculations for the complex roots and calculates alpha and beta here, and the C value and the theta value, which is calculated using the C complex user-defined function and the calc theta user-defined function, which are right here, right here. So the C complex calculates C, calc theta calculates theta. Then those values brought back here and printed out in the output. And theta value is returned in radians. So yeah, that's my script for script one, and then script two I have over here. So the main file for the script, this starts out by asking the user how many zero input responses they'd like to calculate. They'd input that file here, and then we open the data text file to be read so that we can input all the values in the data text file into this array, which is done with this for loop here. And so yeah, that's why I wanted to ask the user how many zero input responses so that I can know how many rows that the code would have to filter through to get all the values from the data text file. And after that's done, I close the data text file here, and then we open the result text file with these code lines here, and then we go through each row or each system and calculate the coefficients and initial conditions of the linear system. And then this is a user-defined function which is in the header file, and this is the file that I used as a parameter for the user-defined function of the header file. So now we'll jump on over to the header file. So the zero input response user-defined function is down here. This is how I use that as the file as a parameter, and I calculated the discriminant using the parameters. And then for non-repeating roots, I use this if statement, calculated the roots, and initialized an array to hold the C values of the non-repeating roots. And I used these user-defined functions to calculate the C values for the non-repeating roots, which are up here. And with this else if statement, I did the calculations for repeating roots by initializing an array, calculating the roots and the C values, which are calculated using the user-defined functions, which are also up here, which are pretty simple since you're just setting a value to a parameter. Anyways, the next was to do complex roots, which is I had to calculate the alpha and beta values using the parameters, and I use the C complex user defined function and the calc theta function to calculate the C and theta values for the complex system. And that is, those user defined functions are stated here. And then I printed the output. So yeah, so going back to the non-repeating roots, this is how the output is supposed to be outputted into the result text file, which is why I use fprintf. And so yeah, it'd be a 1 and the first C value, second C value, and then for repeating roots, it'd be a 2 since it's repeating roots, and first C value and second C value. And then for the complex roots, it'd be a 3 and the C value and the theta value here. And then yeah, all that's returned back to this for loop. So the whole zero input response only calculates the zero input response for one system. So this is why I used a for loop to go through each system and calculate its zero input response. Hey, I also wanted to state that I think the instructions should be more organized because I got very confused when I first read this instructions on how to do the project. So like things like this, like I'm not sure which you wanted or where the header file should have been created for this bottom or the top step. I wasn't sure, and I also the part one script one. I'm guessing we had to make two different scripts, so I did that. So yeah, that's all I wanted to say. It was just if the instructions were a little more organized and clear, that'd be very nice. But yeah, overall, this project was pretty fun in the end.